Hello guys, welcome to the channel. In this particular video, I have explained the problem Bheem Wants Ladoos. So let's get started. Here is the problem statement. Okay, so here is the problem statement and it says that Chota Bheem wants to eat maximum number of ladoos in Dholakpur on Independence Day. The houses in Dholakpur are arranged in the form of a binary tree and have ladoos same as their house number. Let me explain this. So in Dholakpur we have the houses which are arranged in a manner like this. So you can see that this is same as the structure of a binary tree and we have more houses like this. Okay, now let me name them all. So this is house 1, this is H2, this is H3, this is H4, H5, H6 and H7. Okay, now interestingly, the number of ladoos in each house is same as the house number. So if this is H2, then the number of ladoos is going to be H2 for this house. Now Chota Bheem is standing at his home initially. So one of these nodes or one of these houses is the home of Chota Bheem. Let's say this particular node. So this is the home of Chota Bheem and he is standing at this position initially. Now our task is to find the maximum ladoos that he can eat. If he can go to houses within a maximum distance k from his house. So if he is standing at this position, so he can cover all the houses which are at most distance k. Now the number of ladoos at his house is also going to be counted. Okay, now one note is given here which says that every house has distinct ladoos in it. Okay, now one example is given here. Let me explain the example. So the example says that we have the structure of houses like this and the home of Chota Bheem is the node 9. So this particular node is the home of Chota Bheem. Okay, now Chota Bheem can cover all the houses which are at most distance k, which is 1 here. Okay, so from this from his home he can go to this house, he can go to this house and he can go to this house. There is no any house there is no any house left where which he can cover. So these are the houses that he can cover. Okay, now let's see the number of laddus that he can eat. So 1 laddu for this house, again 9 for his own house and 5 and 7. So if we add all the values, then the answer is going to be 22 here. So you can see that the output is 22. Now I hope you guys have understood the problem well. So let's talk about the solution. Okay, so I have taken one example here and we will try to build the equation first. So you can see that we have the structure of houses like this. Okay, and the home of Chota Bheem is the node 19 here. So I have marked this node. Okay, and the distance that he can Chota Bheem can cover is 2 here. Okay, now we know that for a binary tree node, we can go to left node and we can go to right node, right? These are the two pointers that we have. Okay, now this means that we can go to downward direction easily, downward direction. Okay, but if I look here, then you can see that from this 19, in order to cover all the houses, we can go to all the houses in the downward direction, as well as we can go to all the houses in the upward direction. But this particular node doesn't provide us any way to move to upward direction, right? So this is the problem. Okay, so now I can divide the problem into two tasks. The first task is going to be covering all the houses in the downward direction. This is the task 1, and the task 2 is covering all the houses in the upward direction. Okay, and even this may be the case like where we are covering the upward direction, after that we are again covering the downward direction. Let's say for this node the value of k is 6. So for the value being 6, I can cover first this node, second, third, and till now we have covered 3 nodes, right? We can cover 3 more nodes because the value is 6 here. Okay, so I can go to this node, I can go to this node, and I can go to this node, right? And is there any other node that we can cover? So 1, 2, and we can cover these 2 nodes as well, if you notice here, right? Because from this point we need to cover 3 nodes, so 1, 2 and 3. Similarly these nodes. Okay, so now I hope you guys are able to get the intuition. Let me tell you the task that we need to perform. So there are 2 tasks. The first task is sum of nodes in the upward direction, and the second task is sum of nodes in, okay, so sum of nodes in the downward direction for this and sum of nodes in the upward direction for this. Okay, so let's start with the task 1 first. Okay, so I have taken a binary tree as the example in order to explain the sum of nodes in the downward direction. Okay, so I'm going to ask from this node, this is root node, right? This is root node. So I'm going to ask from root node, hey, what is the sum of all the nodes which are at most at distance 2 from you, right? Okay, so let's call it a function which is going to give us the answer. So I'm going to pass the root and I'm going to pass the distance, right? So this is going to take root and distance, and this is going to tell me what is the count of all the nodes which are at up which are at most at this distance from the root, right? Okay, now in order to get this answer, this root is going to ask from these two nodes that, hey, can you tell me what is the sum of nodes from you, from this particular node, which are at most at a distance 1, right? Because the distance between these two nodes is 1. So when I move from this node to this node, then the distance remains 1. Initially the distance was 2 and now the remaining distance is 1. So after that I can cover all the nodes at most at a distance 1 from this node. Okay, and if I know that count, then let's say left is the count. Okay, similarly this node is going to ask from right side as well. Okay, so let's say the right is the answer. Right is the count of all the nodes, is the sum of all the nodes. Okay, now I have the answer, so I can simply return left value, right, plus right value plus root data. I hope it is clear to you that if I know the count of all these nodes and these nodes, then I just need to add these the root data to these values, right? And the total is going to be the answer because I need to find this particular value, right? This particular I need to cover. So the solution to this is obviously going to be left plus right plus root value. Okay, now what is the left and right? Left and right is simply asking from the left and right node. So I'm going to ask same question from the left and right. How to ask the same question? My left value is going to be function of root dot left, right? Root dot left. And after that, my distance will reduce by 1 because whenever I move from one node to another, then the distance reduces by 1. So if distance is 2 for this, then the distance will become 1 for this. Okay, similarly, I have the right value as well. The right value is again function of root dot right. Again I have distance minus 1. Okay, now you can notice one thing from this point, that I am moving my root pointer and I am moving my distance pointer. Okay, so there are two possibilities. One is my root can become 0. If I have n here and I try to move here, then my root will become null, right? So if my root become null, then what to do? This is the question. So my root can be null. Okay, now one more possibility is there. If I'm in decreasing the value of distance by 1 and 1 again, then the distance can become less than 0. And if the distance is less than 0, then I don't need to cover that node, right? Why? Because I need the nodes within the distance 2 here. So when I move like when I exceed this particular limit line, I go to a distance which is more than 2. In that case, I don't need to cover that value, right? So if distance is smaller than 0, in both these cases we are going to return 0. So return 0. Now you can divide this code into 3 parts. We have the first part as the base case, and we have where I'm performing the function call. This is a point where I'm performing the function call, and this is the return value, right? Okay, now I hope the idea is clear to you for the first task that we need to perform. So now let's this is how we are going to get the sum of all the nodes in the downward direction. Fine. After that, our task the second task that we need to do is find the count of all the nodes in the upward direction. Okay, this is pretty interesting. I want you to focus at this point. Okay, so I have taken the same binary tree which was given to us here. Like you can see here that this was the binary tree that was given to us. Okay, so I have taken the same tree here, where the home is 19. Okay, now initially I am given this particular root, right? Initially, if I talk about the given value, then this value is given to us, this root. After that, the home and k value. Okay, so the first task that we need to perform in order to solve the problem is finding this finding the home of Chota Bheem, right? If I am a person who don't know about the home of Chota Bheem, and we are given this value, right, root. So I am starting from this point, and my first task is to find the home of Chota Bheem. Okay, so how to find the home of Chota Bheem? So let's say we have a function solve, and this function has three parameters. The first is root, okay, the second is home itself, and the third is k. We have three values, and there are multiple possibilities. Like if I keep searching on this direction, then you can see that there is one point where I have reached null value, right? So whenever, and even if I go to this direction, then one point will come when I will reach null value. Okay, so what to do in that case? If value is null, let me change the color. So if here root is null, this means that we have not found our we have not found the home of Chota Bheem yet, right? We were moving in the wrong direction in that case. So I can simply return -1. This -1 represents that we have still not found the home of Chota Bheem. Okay, but there is one more case. If root is home, if root is home, what is this case? This case says that if I move here, then I move here, then I move here. So now you can see that my current root is pointing to the home of Chota Bheem, right? Okay, in that case, I need to return 0. This 0 represents that we have found the home of Chota Bheem. Okay, but there is one case. When we are at home of the Chota Bheem, from that point, we need to move downward direction in order to calculate the sum of all the nodes, right? Isn't it? You can see here even this is home of Chota Bheem. So Chota Bheem is going to move from this point, and he's going to cover all the nodes in the downward direction. So how we can cover this? We have a function, this function, which is going to give us the sum of all the nodes, right? So we just need to call this function. I'm going to call this function, let's use green color here. So I have a variable answer which is going to increase by a value which is function root comma k is the distance, right? This is what I need to do. You can see here that I have answer variable which is going to store the answer which is initially 0. Okay, this answer is going to increase whenever we have the found the home of Chota Bheem. So now you can see that when we are at home of Chota Bheem, then we can simply go downward direction. Okay, this is the case for moving downward direction. We have still not covered the case for moving upward direction. Okay, let me explain you how we can cover this case. Let's say we have found the home of Chota Bheem in the left direction, right? Okay, so and the distance from since I have asked from me as a root, have asked from this particular node that what is the distance of root, what is the distance of root from the this node. Okay, so it says that the distance is, let's say, left variable. There is a variable left which is left d, which is going to store the distance of this particular home node from the left node, right? Okay, so I can say that if this distance is left d, then the distance of this particular node, which is our current root node, from the home node is going to be left d plus 1, right? Okay, after that we can make one observation from this point. Let me tell you what. Now let me remove this because this is going to be messy now. Okay, so I know that this distance is left d plus 1. Fine. So, and I need to count the sum of all the nodes at most at a distance k, right? Okay, so if let me tell you one condition. If left plus 1 is smaller than equal to k, what to do in that case? Let me tell you what does this mean first. Okay, this means that let's say we have what is this distance? This is 1 2 3 3 is this distance. Okay, let's say we need to count all the values at a distance at most 4. Okay, so when I come to this point, there is no point, there is no way to move in the upward direction, right? So in that case, since I have found the node in the left direction, so I need to cover all the nodes in the right direction, right? Isn't it? Okay, but to what distance? Like from this I can again go to downward direction in order to calculate the sum of all the nodes, but to which point? What is the distance? If this distance is left plus 1, so what is this distance? Let me change the color. If this distance is left plus 1, then this particular distance is going to be left plus 2, left distance plus 2, right? Do you agree? Okay. After that, I know that k is greater than left plus 1. Okay. So the distance that I need to cover is k minus left distance plus 2. Let me explain this. After this point, I need to cover some more nodes. Let's say n is the nodes that I need to cover. Okay, so I know that this whole value is k, like from this to this, the whole value is k, right? So what is this? What is the value of n that I need to cover? The value of n is going to be k minus ld plus 2. This is what I have written, right? Okay, so this means that if I have found the like node in the left direction in distance k, in so I need to cover all the remaining nodes from the like this particular position, right? Okay, let me write the code for this. You will get the idea yourself. Let me write the code for this. So first of all, I'm going to ask from the like left and right that, hey, do you contain the do you know the path from like to the home of Chota Bheem? Okay, so left, let me remove this. I'm going to make this a little bit thinner. Okay, so my left distance is going to be solve of root dot left comma home comma k, and my right distance is going to be solve root dot left okay, root dot right here comma home comma k. Let me tell you what does this mean. This means that if I'm initially at the root, I'm initially at this root, so I'm going to ask from this node as well as this node that, hey, do you know the path from yourself to the home node? So now you can see that this is going to return -1, right? Because this doesn't know the path. Okay, so there are two possibilities. Either the path is found by this RD or LD. Okay, how to detect that? So if the node is present in the left subtree, then LD will not be equal to -1. So LD is not equal to -1 in that case. Okay, I need to check that condition. After that, if the like the home node is present in the right subtree, in that case RD will not be equal to -1. In that case, RD will not be equal to minus. Let me write this. If RD, okay, I've written rod here. So if RD is not equal to -1, this is one of the conditions. Okay, I have two possible conditions. Now, what to do inside these? Inside these, I'm going to write a simple logic that if this condition is true, like if left plus 1, like LD plus 1 is smaller than equal to k, in that case, okay, and same condition is here. If RD plus 1 is smaller than equal to k. Okay, now what to do in this condition? In this condition, let's say, let me explain you again this thing. Okay, so if the node is found in the left direction and I know that this distance is greater than k, so I need to travel in this subtree, in the right subtree, because I can add up like I can eat more laddus in the right subtree. Okay, so I'm going to move to right subtree and I'm going to calculate the sum of all the nodes in the downward direction. How to do this? How to do this? In order to do this, we have a function, right? Again, let me show you this function. We have this function. So we are going to do a simple thing that answer is going to increase. Answer plus equals to, I'll do that. Okay, I'll do function of, since the home is found in the left subtree, so I'm going to move to right. Root dot right, comma, k minus LD plus 2. I have already explained this to you. What is this distance? Okay, and same thing here as well. Answer plus equals to function of root dot left here. In that case, I'll move to left subtree and k minus RD plus 2. I hope this idea is clear to you. Okay, after that, since my node is found in the left subtree, so I need to return the distance, right? So let me remove this. I need to return the distance in that case. So I'm going to return the distance as return LD plus 1, because this is the total distance of home node from this from the current node. Okay, and what about this? In that case, I'll return RD plus 1. Okay, and if the root is not like if the home node is neither found in the left subtree or nor in the right subtree, in that case I need to return -1. return -1. This is the simple logic that we need to do. Let me zoom this out. Okay, so this is the simple logic that we need to perform. I hope the idea behind this is very simple, like clear to you. So you can see here, the first of all, I'm checking the base condition if my root is null or root is home. In that case, I need to do this task. After that, I'm calling the function. After that, this is the main logic that we have to do. Okay, now let me show you the code. So here I have written the Java code, Python code, and the C++ code. So you can see that on the left hand side I have written the Java code. And let's start with the starting point. So this is the starting point, which is the function Ladoos. And here I am initializing my answer as 0. After that I'm calling the solve function here. And after that at the end I'm returning the answer. Okay, what is the solve function? You can see the solve function, which is very similar to the one I have explained you. You can see here that I have a left distance and the right distance. Okay, and before that I'm checking these two conditions. Okay, fine. Now if my left distance is equal to is not equal to -1, in that case I have found the node in the left direction. Which node I'm talking about? I'm talking about the home node. Okay, after that this condition may also be true, that if I have found the home node in the right subtree. Okay, in that case I need to do this task. Okay, so at last I need to return -1 if I have not found like the home node in any of the subtrees. The same thing I'm doing here as well in the C++ code. And let me show you the Python code as well. So this is the Python code that I have written. Okay, so this is all about this problem. I hope you guys will like this solution, and if you like the solution, then you can hit the like button and share the video, and also subscribe the channel if you are new here. So this is all about this video. Thank you.